As soon as it starts, I will start the class. Okay. So next topic is SF6 circuit breaker. So SF6 circuit breaker is the circuit breaker in which the circuit breaker contacts are placed in a medium. Okay, that medium is sulfur hexafluoride gas. Okay, so in SF6 gas, circuit breaker contacts are placed in this SF6 circuit breaker. Okay, the SF6 is an electronegative gas and has strong tendency to absorb free electrons. Okay, so you might be already knowing about SF6 gas. So SF6 is an electronegative gas which has strong tendency to absorb the free electrons. So this property of absorbing free electrons is utilized here to quench the arc or to extinguish the arc. Okay, so the contacts of the breaker, whenever the circuit breaker contacts are open in the in a high pressure flow of SF6 gas. Okay, so when arc is struck between the contacts, this high pressure flow of SF6 gas will take away the heat from this arc, and arc will be extinguished at some current zero point. Okay, so the conducting free electrons in the arc are rapidly captured by this gas to form relatively immobile negative ions. Okay, so when this arc comes in contact with this high pressure flow of SF6 gas, okay, the free electrons of the arc are captured by this gas to form relatively immobile negative ions. Okay, you can see this is SF6 molecular structure. So this SF6 circuit breaker. Okay, this is SF6 circuit breaker. So this loss of conducting electrons in the arc will quickly build up enough insulation strength to extinguish the arc. Okay. So SF6 circuit breaker have been found to be very effective for high power and very high voltage services for interrupting the fault currents. Okay, you can see an image of SF6 circuit breaker. Okay, so let us initially, before discussing about the operation of SF6 circuit breaker, let us discuss some properties of SF6 gas. Okay, so let us discuss the physical properties of this SF6 gas and chemical properties and electrical properties of this SF6 gas. So let us start with physical properties of this SF6 gas. So this SF6 gas is colorless, odorless, non-toxic and non-inflammable gas. Okay, so this SF6 gas is colorless, odorless, non-toxic and non-inflammable gas. It is a pure gas. Okay, so if under pure condition, okay, it is not harmful to health. Okay, so pure gas, pure SF6 gas is not harmful to health, and it is in gas state at normal temperature and pressure. Okay, so this SF6 gas will be in gas state at normal temperature and pressure. Okay, so it is a heavy gas having density of around 5 times to that of air at 20 degrees Celsius. Okay, so the density of this SF6 gas is 5 times to that of air at 20 degrees Celsius and atmospheric pressure. Okay, so this gas will start liquefying at a certain low temperatures. Okay, so of course at normal temperature and pressure, this gas, the state of this gas is in gaseous form, but this gas will start liquefying at certain low temperatures. This liquefying temperature depends on the pressure. Okay, so the liquefying temperature, at what temperature this gas will convert into liquid. Okay, so the liquefying temperature will depend on the pressure. So at 15 atmospheric pressure, the gas will liquefy at a temperature of around 10 degrees Celsius. Okay, so it is observed that at 15 atmospheric pressure, the gas will liquefy at a temperature of around 10 degrees Celsius. Okay. So, it has an excellent heat transfer property. The heat transfer capability of SF6 is 2 to 2.5 times to that of air at same pressure. Okay, under same pressure, if you compare the heat transfer capability of this SF6 with air, so SF6 can transfer 2 to 2.5 times to that of the capacity of air. Okay, and the heat content property is much higher than air. The heat content property of SF6 is much higher than air. So this property of SF6 assists cooling of earth space after current zero. Okay, so because heat content property is much higher than air, this property of this SF6 is utilized for cooling the earth space after current zero. Okay, these are all the physical properties. Let us discuss the chemical properties. Okay, let us discuss the chemical properties of SF6 gas. So it is chemically stable at atmospheric pressure and at a temperature up to 500 degrees Celsius. Okay, so this SF6 gas will be stable at atmospheric pressure and up to a temperature of 500 degrees Celsius. And it is chemically inert gas. Okay, so because it is chemically inert, because of this property, it has exceptionally low reactivity and does not attack metals, glass, or plastic. Okay, so this SF6 gas is a chemically inert gas. Because of this chemically inert property, it has exceptionally low reactivity and does not attack metals, glasses, or plastics. Okay, the life of the contacts, circuit breaker contacts, and all the metallic parts is longer in SF6 gas. Okay, the components do not get oxidized or deteriorated. Okay, these components, when they are uh, under the influence of SF6 gas, they do not get oxidized or deteriorated. Hence, the maintenance required is reduced.
Excuse me, ma'am. Your voice is breaking, ma'am.
Okay, so the maintenance required will be reduced. Why? Because the components which are in SF6 gas will not oxidize. Okay, so moisture is very harmful to the properties of this gas. Okay, so in the presence of moisture, hydrogen chloride is formed during iron, which can attack the metallic insulin part of the circuit. Okay, then moisture should not enter the circuit. If moisture enters the circuit, metallic insulin Are you able to hear me? Can anybody inform me? Is my voice audible to you? Are you able to hear me? Yes? Okay then, I will continue. Okay, so do you want me to repeat these chemical properties? Okay, once again I am repeating these chemical properties of SF6 gas. So SF6 gas is chemically stable at atmospheric pressure and at a temperature up to 400 degrees Celsius. Okay, so it is a chemically inert gas. Okay, since it is a chemically inert gas, because of this property, it has exceptionally low reactivity and it will not attack metals, glass, or plastics. Okay, so the life of the contacts and the other metallic parts within the circuit breaker is longer in SF6 gas. Okay, and these contacts and metal parts of the circuit breaker, which are in contact with SF6 gas, do not get oxidized or deteriorated. Hence, maintenance requirement is very less. Okay, we can say that it is one of the advantage of using SF6 gas as the air polluting medium because maintenance requirement is reduced here. Okay, so the moisture is very harmful to the properties of this gas. Okay, so in the presence of moisture, it is observed that hydrogen fluoride is formed during arcing, which can attack the metallic and insulating parts of the circuit breaker. So we must make sure that it is airtight. No moisture should enter. Okay, should not allow any moisture to enter into the circuit breaker. Okay, otherwise during arcing period, what will happen is hydrogen fluorides are formed. Okay. So it is non-corrosive in all metals at ambient temperatures. This SF6 gas is non-corrosive on all metals at ambient temperatures, and it is a electronegative gas. Okay, so electronegativity is the ability of an atom to attract and hold electrons. Okay, it's an electronegative gas. Electronegativity you might be already knowing. You might have learned it in your exam itself. Electronegativity means it is the ability of an atom to attract and hold electrons. Okay, so this SF6 is an electronegative gas, so it has the ability to attract and hold electrons. So because of this electronegativity, the arc time constant of SF6 gas is very low. Arc time constant means the time between current zero and the instant at which conductance of the contact space reaches zero value. Okay, arc time constant means what? It is the time between current zero, okay, and the instant at which conductance of contact space reaches zero value. Okay, therefore, this because of this electronegativity property of this SF6 gas, the arc time constant of SF6 gas is very low. Okay, it is less than 1 microsecond. Okay, so the arc time constant of SF6 gas is very low, that is less than 1 microsecond. Okay, and the rate of rise of dielectric strength is very high. Okay, rate of rise of dielectric strength is very high. Hence, SF6 circuit breakers are suitable for switching conditions involving high rate of rise of restriking voltage. Okay, so the products of decomposition of SF6 recombining into a short time after arc extinction. Okay, so the SF6 gas, when it comes to contact with arc in the circuit breaker, it just decomposes. Okay, and later on, as soon as arc is extinguished, it just recombines. Okay, so the products of the decomposition of SF6 recombine in a short time after arc extinction, and during arc extinction process, SF6 will decompose. Okay, while extinguishing the arc, SF6 will decompose to some extent into SF4, SF2, S2, F2, S, and F. Okay, so the SF6 will decompose while extinguishing the R into SF4, SF2, S2, F2, S, and F at temperature of around 1000 degrees Celsius. Okay, at temperature of around 1000 degrees Celsius, this SF6 gas will decompose into SF4, SF2, S2, F2, and S. The products of decomposition recombine to form the original gas in a very short time upon cooling. Okay, so these products SF4, SF2, S2, F2, S, and F will once again recombine to form SF6 within a short period upon cooling. Okay, so the remainder of the decomposition products is absorbed by a mixture of soda, lime, and activated aluminium. Okay, so if any component which is not recombined into SF6. Okay, so any form that among SF4, SF2, S2, F2, S, and F, if any form is not recombined into SF6, that can be absorbed by a mixture of soda, lime, and activated aluminum. Okay, so these are all the chemical properties. Okay, so let us discuss electrical properties of SF6 gas. Okay, so electrical properties of SF6 gas are dielectric properties, corona inception voltage, dielectric constant, and arc interrupting capacity. Okay, so let us discuss these properties in detail. So SF6 gas is highly electronegative. It's not have only. Okay, due to high electronegativity, it can absorb free electrons which are produced due to arcing between the contacts of the circuit breaker. Okay. So, combination of free electrons with the molecules produces heavy and weak ions which have very low mobility. Okay. So, when the free electrons are combined with molecules, they will produce very heavy and weak ions which have very low mobility, and because of the absorption of free electrons and low mobility of these ions, SF6 has okay SF6 has very excellent dielectric property. Okay, so because of the absorption of free electrons and low mobility of ions, SF6 has very excellent dielectric property, and the dielectric strength of SF6 gas is 2.5 times more than that of the air. Okay, next one is corona inception voltage. So first of all, we must know what is corona inception voltage. So corona inception voltage is the lowest voltage at which continuous corona of specified pulse amplitude occurs as the applied voltage is gradually increased. You know what is meant by corona, isn't it? You already know what is meant by corona effect. You know that. So corona inception voltage is the lowest voltage at which continuous corona of specified pulse amplitude occurs as the applied voltage is gradually increased. Okay, that is known as corona inception voltage. Okay, so corona inception voltage of SF6 in a non-uniform electric field is also considerably higher than that of air. Okay, so the corona inception voltage in a non-uniform electric field of this SF6 is higher than that of air. Okay, next one is dielectric constant. Okay, so because of being non-polar, that is dipole moment is zero. Okay, non-polar means dipole moment of this molecule. Constant of SF6 is independent of the frequency of the applied voltage. Okay, so since SF6 gas molecules are non-polar, hence SF6 is the direct constant of SF6 is independent of the frequency of the applied voltage. Further, the direct constant changes by only 7%. Okay, the direct constant changes by only 7% over a pressure range of 0 to 22 atmosphere. Okay, so next one is arc interrupting capacity. So molecules of SF6 and dissociated armies and okay. Okay. So the arc temperature in SF6 is lower than the in for same arc current and radius. Okay, so for the same arc current and radius, the arc temperature in SF6 gas is lower than the arc temperature in the air. Okay, so whenever I say air, that means that I'm talking about air circuit breaker. Okay, I'm talking about air circuit breaker in which air is this arc quenching medium. Okay, so the high heat transfer capability and low arc temperature. Okay, so high heat transfer capability of this SF6 gas and low arc temperature. The temperature of the arc is low in SF6 gas. Okay, so when compared to air, the arc temperature will be low in SF6 gas. Also provides an excellent arc quenching capacity of SF6. Okay, so the SF6 has high arc interrupting capability because it has high heat transfer capability and low arc temperature. Okay, so let us see the construction of SF6 gas. Construction of SF6 gas. So this SF6, sorry, not SF6 gas, SF6 circuit, SF6 circuit breaker. Construction of SF6 circuit breaker. Okay, so SF6 circuit breaker mainly consists of two
Ma'am,
parts.
screen is not visible, ma'am.
Screen is not visible. Okay, you might have informed earlier. It didn't inform you. Did you text message? Okay, I told you I'm using some other. Okay. One minute. So screen is not visible from past how many minutes? You didn't observe? Okay then. So construction of SF6 circuit breaker. So SF6, is it visible now? Can anybody inform?
Yes, ma'am.
Okay then. So SF6 circuit breaker mainly consists of two parts. One is interrupter unit and gas system. Okay, so you can see this is it. So this is the interrupter unit. Okay, and gas system actually it is not shown here, but gas. This is the inlet for the gas into the circuit breaker. Okay, so if you consider interrupter unit, this unit consists of moving contacts. Okay, this one and this yellow portion. If you see, this is the moving contact and fixed contact. This is the fixed contact. This yellow portion. You see, this is the fixed contact. Okay, and it also consists of arcing horn. Okay, this is the arcing horn. So this interrupter consists of moving contacts, fixed contacts, and arcing horn. Okay, so it is connected to a gas SF6 gas reservoir. Okay, so this interrupter is connected to a SF6 gas reservoir the unit consists of slide vents in the moving contacts. Okay, so it has slide vents. Okay, you can see this slope on this moving contacts. Okay, so this unit consists of slide vents in the moving contacts which permits the high pressure gas into the main tank. Okay, so if this moving contact permits high pressure gas from this SF6 gas reservoir into this main tank. Okay, so next let us discuss about this gas system, the reservoir in which gas is filled. So the closed circuit gas system is employed in SF6 circuit breaker. Okay, so SF6 gas is costly, so it is reclaimed after each operation. Means for interrupting the arc through this SF6 gas inlet, the gas is allowed to flow into the circuit breaker and it is taken back. Okay, it is reclaimed after each operation. Okay, because it is not contaminated. Okay, it is not decomposed to any other component. Okay, even if the SF6 gas while interrupting the arc, it just means these molecules will split into SF4, SF2, and SF and all. Okay, S2F and all, but these molecules will recombine to form while cooling. They will recombine after extinguishing the arc. They will recombine to form SF6 gas. Okay, so this unit consists of low and high pressure chambers. Okay, so and with a low pressure alarm along with the warning switch. There will be a low pressure alarm and there will be a warning switch here. So when the pressure of the gas is very low, due to which direct strength of the gas decreases, and an arc quenching ability of the breaker is endangered. Okay, then the warning alarm will blow out to give warning to the engineer who is monitoring the operation of this circuit breaker. Okay. So let us discuss the working of this circuit breaker, SF6 circuit breaker. Okay, this is an SF6 circuit breaker. This is the interrupter. Okay, insulating stack on which interrupter is placed. The operating mechanism, control panel. Okay, so this is an SF6 circuit breaker. So let's discuss the working of SF6 circuit breaker. Okay, so it is consisting of slide moving contacts and fixed contacts that you already know. Okay, and arcing horns. Okay, so let us discuss the working. So in the normal operating condition, what will happen? The moving contact will be in contact with the fixed contact. Okay, so moving contact will be in contact. These are the fixed contacts. Right side contacts are the fixed contact. Left side contacts. This one and this one are the moving contacts. Okay. So under normal operating condition, the contacts of the circuit breaker are closed. Okay. When fault occurs in the system, the moving contact is pulled away from the fixed contact and arc is struck between the moving contact and the fixed contact. Okay. So the displacement of the moving contact is synchronized with the valve which enters the high pressure SF6 gas. Okay. So I have told you that there will be an SF6 inlet will be there. Okay. So to that inlet, this moving contact will be synchronized. So as soon as moving contact is moved away from the fixed contact, the inlet of this SF6 gas is also opens. Okay, it also opens. Okay, so the displacement of this moving contact is synchronized with the valve which enters the high pressure SF6 gas in the arc interrupting chamber. This is the arc interrupting chamber. Okay. And the gas which is entered into this arc interrupting chamber, the SF6 gas which is entered into this arc interrupting chamber, it will be at a pressure of 16 kg per centimeter square. Okay, so the pressure of this SF6 gas will be around 60 kg per centimeter square. The SF6 gas will absorb the free electrons in the arc as soon as this SF6 gas comes in contact with the arc which is stuck between the contacts. It will absorb the free electrons. Arc is not shown in this image, but you can imagine an arc in contacts. Okay, so SF6 gas will absorb the free electrons in the arc path and forms ions which do not act as a charge carriers. Okay, so these ions increase the dielectric strength, okay, of the gas, and hence arc is extinguished. So the process reduces the pressure of SF6 gas up to 3 kg per centimeter square. So when the SF6 gas entered this chamber at a pressure of when the pressure of this SF6 gas was 16 kg per centimeter square, but after entering this chamber and extinguishing the arc, the pressure becomes, it reduces to 3 kg per centimeter square. Okay, so thus it is stored in a low pressure reservoir. So this low pressure gas is pulled back to high pressure reservoir for reuse. Okay, even after extinguishing the arc from the low pressure reservoir, it is pulled back to the high pressure reservoir in order to reuse it. Okay. Nowadays, buffer piston pressure type SF6 circuit breakers are used for quenching the at high pressure. Okay. So, and there will be a piston attached to the moving contact. Okay. So to develop the pressure within the chamber. How the pressure is developed within the chamber with the help of a piston, we will discuss in detail in the next class. Okay, in different types of circuit breakers. We are discussing about different types of circuit breakers. So one type of circuit breaker is buffer type circuit breaker or single pressure type circuit breaker. Another type is double pressure type circuit breaker. Okay, so we'll discuss types of circuit breakers in the next class.